So the umbra is the complete shadow. The penumbra is the partial shadow, where it's partially blocked. It's like if you're looking at something, you can, I can't see it out of one eye, but you can see it out of the other. All right. So only happens during the full moon phase. Go ahead and write that down. And so what we have here is the photograph, 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 where they click, 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 click as it goes along. And what you can see here is the full moon. It's the full moon. It gets a little bit dimmer because what's happening when it's dimmer, it's getting into the Earth's penumbra. Now, there's a penumbral eclipse, all it looks like is the moon is a little bit dimmer than normal. It happens. People aren't even going to notice it. It's like a cloud moves in front of the moon. You're not going to pay attention unless you happen to know what's going on and really paying attention. But when the full shadow, the umbra of the Earth starts moving across, and as time goes along, and what's going on then is the moon is moving through the Earth's shadow as it goes around. And it takes like 29 days to go around. So here it's moving into the Earth's shadow until it gets completely covered, right? And when it gets completely covered, something interesting happens. We'll get to in a second. If the Earth had no atmosphere, it would be totally dark because that'd be the only light source, and it's all gone. But it doesn't get totally dark, right? What happens is the light goes through the Earth's atmosphere and gets refracted. The sun's light gets refracted through the atmosphere, and that's why it looks red, because that's the light of the sunrises and sunsets on the Earth. But here's a picture of an eclipse going on there. You can see the Earth's shadow. Notice that the curvature is, it's not as small of a circle as the moon is. That's because the Earth is larger than the moon. In fact, the ancient Greeks, some of them figured out how big the Earth and moon are relative to each other by looking at the eclipse going, oh, look, the Earth is round and it's bigger than the moon. So the idea that people always thought that the Earth was flat, no, not necessarily. There were a lot of the ancient Greek, people that knew that. But here's the deal, is why doesn't it happen every month, right? If you have a situation where you have the moon going around the Earth and you got the sun there, why doesn't it block every single time? Well, the answer is because the orbit of the moon is tilted just a little bit. Now keep in mind the scale on this is completely kablooey, right? The distance and the size here is not even remotely close. But the moon and the Earth is actually about the right size, but it's pretty far away. It would actually, an accurate scale for the Earth would really be probably, let me see if I can get the Earth in there, a little further than that, actually. But so it's tilted a little bit. So just a little bit of tilt will make it sling. Let's get this in out of there. It doesn't always go right through the shadow, right? It sometimes goes over the shadow or under the shadow. It sometimes goes, well, let's do it with this. Sometimes it goes underneath the shadow of the Earth, like this. And depending on where it is on its rotation, it might go underneath the shadow. Okay, so that tilt, the only time you get an eclipse is when it's lined right up with, it's called the node, the ascending and descending nodes. It's only when that tilted orbit of the moon around the Earth lines up perfectly, and that would be basically twice a year. Except here we have a picture of, hopefully you can see here, you have the ascending node where it's going upward, and right here where it intersects, that's where you could have the eclipse, depending on the angle of the sun. And the white line would be if it's flat, the plane of the ecliptic of the sun. The yellow is the actual plane of the orbit of the moon. So here it kind of goes underneath, and here it goes up over top. The only time you're going to have an eclipse is when it lines up right in these directions, okay? Happens about twice a year, visible from half the Earth. And so, yeah, you can see this one here is a interesting thing. I like this sequence here. You can see it gets dimmer because it's moving in the penumbra of the Earth. And then here's the umbra moving across it. They changed the camera here, and notice it's this bright red. They call that the blood moon sometimes. what happens with the blood moon, what's going on is it's the Earth has an atmosphere, and when the light goes through the Earth's atmosphere, well, it refracts. There's something called refraction, the bending of light. It's like how your eyeglasses work to correct your vision, is it bends the light. So when it goes through, it bends downward. The red now is what gets through when you have that much atmosphere. That's why you have red sunsets and sunrises, right? So it's actually the light from all the Earth's sunrises and sunsets that's shining on the moon, and that's why it has that reddish color. Okay? If the Earth had no atmosphere, it would be totally dark.